Now I will explain question 2a, which asks us to write an algorithm that uses Bayes' theorem for decision making. On the screen you can see the slide from our presentation where I have shown both the general idea and 2 real examples, one for the students and one for the crime. Let me start by explaining the Bayesian decision making process. Bayesian theorem allows us to update our beliefs about an event after observing some new evidence. The general algorithm goes like this. First step is to define the prior probabilities. These are the initial probabilities before we can see any new data. In the student example, the prior probabilities are 0.75 and 0.25 of pass and fail respectively. Second step is to define likelihood. These tells us how likely a particular piece of evidence is given a certain condition. For example, on my slide, probability of attendance being lower than 60% given that it is fail is 0.85, and probability of attendance is less than 60% given that it is pass is 0.15. This means the weak students usually have low attendance, whereas good students rarely do. Third step is observe the evidence. Evidence here is student X has 55% attendance. This is the input to our Bayesian decision making. Step 4, apply the Bayes theorem. Now we compute the posterior probability. Probability of 4 given that it has lower attendance is equal to likelihood into prior probability divided by total probability, like given here. I'll also write the formula for it, which is likelihood into prior divided by total. Okay, so probability of student being failed having given that it has low attendance is 0.65 after calculating this all. 65% is the fail risk. This is how Bayes' theorem makes a smarter decision than simply guessing based on attendance alone. Now let us see another example, which is crime example. On the right hand side of the slide, I have shown another real scenario. P of dowry death is 0.12 and P of burn plus marriage, which is less than 7 years, given that dowry death is 95%. P of burn plus marriage less than 7 years not is 0.08. So if a case has both burn injuries and marriage duration under 7 years, Bayesian theorem calculates 61% chance that it is BNS 80, dowry death. This shows how police department can use statistical reasoning to try cases, identify high risk, fire and support legal decision making. So this completes question 2a, and I have shown the full Bayesian algorithm. Now let's move on to question 2b, which is write any suitable algorithm for association rule mining that can print all association rules. Okay, so I have explained Apriori algorithm in my presentation along with both crime related and student related rule examples. Association rule mining helps us discover patterns, like if a student submits all video assignments, they usually score high, or if a dowry demand and burn injury are present, the case leads to a specific BNS section. Let me go through the full algorithm step by step. First, we generate candidate one item from C1. Then we scan the database once and count how many items each item appears. Second, prune to obtain frequent one item sets L1. If an item isn't supposed greater than or equal to minimum support, for example 5%, we keep it, otherwise we discard it. Second step, iteratively generate larger item sets. We now generate 2 item sets, 3 item sets, and so on. 2.1, candidate generation, join steps. We join LK minus 1 with except to form candidate item set CK. For example, A and B are frequent, so we join them to form A and B, like this. A and B, these both are frequent, so we'll join them to form A, B. Now pruning step 2.2, if any subset or candidate item set is not frequent, we remove that candidate. This ensures efficiency. 2.3 is counting support. We again scan the database to count support for each candidate in CK. 2.4, create frequent item sets LK. All item sets with support greater than minimum support becomes part of the LK. We repeat this process until no more frequent item sets can be found. Moving on to the step 3, for each, which is generate association rules. For each frequent item F with size greater than or equal to 2, generate all non-empty subsets S of F. Each subset S represents a potential left side of a rule. 3.2, compute confidence. Confidence is given by this rule, support of F divided by support of S. This tells us how strong the rule is. Now, third, we have to calculate, select valid rules. If confidence is greater than 80% or whatever threshold is given, we accept the rule. This produces all the association rules that satisfy both minimum support and minimum confidence. Example on the slides you can see is crime rules. Dowry demand equal to years and marriage is less than 7 years, burn injury. We apply BNS 80 with 96% of confidence. This indicates a very strong relationship in real FIR data. And weapons equal to quantity pistol, land dispute equal to years. Then we apply BNS 1031 murder with the confidence of 91%. We get. Student rules. Video assignment 1 year, video assignment 2 years, video assignment 3 years, and SEM is greater than 70 with a confidence of 94%. Test 1 is less than 12, quiz average is less than 40, and SEM is less than 40, fails, so with a confidence of 97%. These rules help the teacher identify high performing and at risk students. So this was the complete explanation for Apriori algorithm. Hope you find it well. We'll cover the next question in the next videos. Thank you.